Why aren't you guys in a listening mood? It's the middle of the day.
Because we just saw a horrible everything.
It like puts everything in perspective. That like, oh, that doesn't really
Matter.
physics test. No, it doesn't really matter.
I will concede. Kind of heart-wrenching, kind of terrifying.
It's just
The
sad
best
we don't
way
talk
to-
about it.
And nobody
Yes.
knows anything.
No,
But-
the only reason I knew is because I asked Layla what is going on. Like,
You're actually still early. It's just that, you know, you guys have like half an hour.
Yeah, how is that possible? How did we have half an hour?
Because the speeches took like 3 minutes when they were supposed to take closer to 20. And then Layla's presentation took about 20 when it was supposed to take 20. So there was a lot of time left for some.
Yeah, let's do this test tomorrow.
All right. So stuff that's coming up. There's a test tomorrow, right? Yes.
Yeah.
You remember this? The test is on optics, so plane mirrors, spherical mirrors, lenses, and waves. There are going to be 4 questions on the test.
What? That's it?
Every test has had like 3 or 4 questions without
I guess I
fail.
just never realized that. Like with ABC.
Plane mirror, curved
The-
mirror, lens.
Oh, just on lens or just on mirrors? No.
No.
The whole entire test has 4 questions.
The first question is a mega mirror question.
What do you mean a mega mirror?
It has everything to do with mirrors in the
Oh.
first question. It has F parts. F. Yes, E is 5. It's, you know, letter number conversions.
So you made the test.
I have made the test I'm giving you tomorrow. Easily within, you know, more than 24 hours in advance of giving it. Because I am a professional.
I'm sorry, that really made me laugh.
Is that why you laughed? Because it made you laugh?
Stop.
I'm glad we're recording this for posterity.
Oh, okay.
Alright, so first question has everything to do with mirrors. Plane mirrors, convex mirrors, concave mirrors. All of that will be in the first question. We'll be responsible for the math end of it and for the picture end of it. Alright? Yes.
Will you give us equations?
I will give you the equations, all like 2 of them, as I have for every test.
We need the chart.
If you want to use it, you will need it. I will not be posting the chart this time.
Would it be helpful?
Oh yeah.
I would think so, since it has like all of the answers for like generic answers for every result.
How many charts do we have? 2?
You have 1 chart for mirrors and 1 chart for lenses. Oh, at this point,
What is
here.
the difference?
Light bounces off a mirror and it goes through a lens. Let me.
Light goes through a mirror.
Light bounces off a mirror and goes through a lens.
We have all
Yeah,
the
it's
stuff
like
that
lenses.
Okay, wait, so they got mirrors, what?
Each one is waves.
Justin?
At this point, I believe I have returned all of the homework I have received, so if you haven't gotten it back, it's because you either didn't give it to me, or it vanished into the gaping maw that is the abyss, which is my desk. But I'm pretty sure that didn't happen much.
Oh. Did I do that?
These are people who turned it in later,
Oh.
almost universally. Yes, you will have to draw things. Alright, so first question has everything in mirrors on it. The second question, you do not have, it has 2 parts, but you choose which one to do. It is on lenses. Maybe. That might seem a reasonable dichotomy of options, but I'm just saying there are going to be choices on the second question. You will not be responsible for all of lenses. You might want to make sure that you are comfortable with all parts of it in case the first option, which involves something, is not as appealing as the second option, or the second option is not appealing as the first option. But there will be a choice. You can do whichever one you can pick the part that you are more comfortable with. The third question is on waves. It is a wave kind of structure question. So you gotta look at that picture of a wave, lenses. First question is mirrors. Second question is lenses. 3 and 4 are both on waves.
What about waves?
That's what I was just getting to.
Okay.
So, number 3 is talking about kind of the structure of the wave. So you got to remember that picture that we drew that had amplitude, wavelength. We talked about frequencies, wave speed.
Yeah, but what about it?
You might need to be able to like label that picture.
Thank you.
Not going for high concept stuff here.
So like label what? Like this?
Yes, like that.
Oh, like wave speed.
Yeah.
Show you where the wave speed.
Or they say what the wave speed is, or show what the wavelength is, or show what the
How do we
amplitude
find the
is.
speed and the length? The equations. Are you gonna provide them? Yes. Okay.
All right.
Are all equations provided except for the charts which are not provided?
Yes. I mean, there are only 3 equations, so yes.
How many worksheets were there?
4 worksheets. Plane mirrors, spherical mirrors, lenses, and waves. The 4th question is then going to be talking about kind of wave stuff. So the wave stuff, the examples of that we had were the Doppler effect and the 2-slit experiment. So again, it will be a choice. Basically, I'm going to be asking you some stuff about the Doppler effect. I'm going to be asking you some stuff about the 2-slit experiment, and you're going to have options to pick from. The 2-slit experiment and the Doppler effect.
What was the 2-slit experiment? Is that the thing when
So it was with the sand and the light. With the sand, you had 2 bumps, and with the light, you had a whole bunch of bumps. You had this
The Doppler effect is the one where you like spun that thing.
Yeah.
versus.
Just explaining what that means.
So it's kind of talking about the basic ideas here. So, like the 2-slit thing is talking about interference. This kind of pattern only happens. Oh God, that's
Oh God.
Excuse me. Yeah, you thought that was nasty. How do you think it felt on my end? And I recorded that and uploaded it.
Veins on your head.
What?
You have like distinct veins when you like get upset.
And they're on YouTube.
Just gonna lecture like this for the rest of the class.
Okay,
It's
okay,
cool.
just go.
Alright, so this is an example of wave behavior. So when
Sorry, I'm so sorry. Wait, is this on question 4?
yes. So when we see waves interfering with each other, that's the kind of pattern that we get. If it's water waves, if it's sound waves, if it's light waves.
Which one?
The bottom one. The top one is if it's particles. So if we tossed sand, if we poured sand through 2 slits, we would expect 2 piles of sand near each other. Alright? So the fact that when light goes through, we see the series of interfering bumps instead of the 2 bumps. So that tells us that light is not behaving like a particle and it's behaving like a wave. That's basically all there is to that. I mean, it's not like you're not going to have to justify where these peaks are, which is kind of where this goes if you're in a college level course. You're not going to have to justify why this happens. I'm not going to be asking for like extreme examples of how interference happens. I want you to be able to distinguish between what happens if it's a particle, what happens if it's a wave.
So that's top is particle.
Top is particle, bottom is wave.
So the difference between a particle is one is
So this demonstrates interference. Waves can interfere with each other. So if I get 2 waves coming in, they can get to one point and be like, oh, I'm constructively interfering. Or they can come to one point and be, oh, I am destructively interfering. If I get 2 particles of sand, they come to one point and, oh, 2 particles of sand. If I get 2 particles of sand, they come to one point, oh, 2 particles of sand. It's not like I have sand and like anti-sand coming in here or something.
So the waves.
Certainly I wouldn't be able to observe it if I had sand and anti-sand.
when 2 waves come together, they create the.
So when 2 waves come together, you can either get constructive interference, where you get a big, where it's a very bright spot, or you can get destructive interference, where it's a very dark spot.
And then sand is just sand.
Sand, you don't have bright sand and dull sand. You get more sand here because it's under the slit.
The constructive was the light.
If it's bright, it's constructive interference. The big idea is this idea of interference. Waves can interfere with each other.
Can we draw some pictures?
What kind of pictures would you like?
What's a lambda?
This?
Yeah.
But we're
wavelength.
The wavelength.
Yeah.
So is it like a unit of wavelength?
It's the just like v is the symbol for velocity, lambda is the symbol for wavelength. All right.
A lambda.
Lambda. Yep. Save that one on YouTube for posterity. 10,000 years from now, all they're gonna know about physics is lambda.
Still recording yourself.
Yeah, I know I am. I'm saving this for posterity. This is comic genius here.
Is it really?
Oh yeah. I'm gonna watch this in preparation for next year. Like, oh, lambda, I gotta bust that out earlier. Really kind of milk it.
You know
Just like,
how
you guys could have a normal physics teacher, but instead you got me.
Wait, are you recording in 4?
Yeah, it's mostly. I don't know if it's gonna show up on the like. I don't know if this blue is gonna record well enough or not. It looks like it's kind of visible.
can we
What else do you
You're
want?
gonna show up.
for the optics lens quiz that I failed?
Yes. Oh, so here's the big thing.
Why?
One of the most common mistakes was, so here's the equation we were dealing with for lenses and for mirrors and for kind of everything, right? This and this are not the same.
I know.
I kind of wish that more people do that.
So you have to add them together before.
Yeah. You can flip them when it's a fraction and a fraction, not when it's a bunch of fractions and a fraction. All right? Not the same.
No, you guys are being
Okay. Perhaps we should do it.
I wish I was being sarcastic and
So, like,
emphasizing this,
Are they
but
the same? No. I know. I know. Sorry.
So what the heck did I do wrong? For number 2.
Don't fail. What do you find this on YouTube so we can go and see it? So we can see it.
yeah. So 1 over di equals 35. That's not really true.
I didn't even so what is the answer?
1 over 35.
Wait, which
See,
way?
I knew that, but then again I was like,
Yes.
What else do you know about the Doppler effect other than like it's higher and lower?
So the idea of the Doppler effect, we had 2 examples of the Doppler effect, right? What were the 2 examples we had? So we had the annoying spinning thing, and because somebody asked, Abby asked.
Galactic redshift.
And galactic redshift was the other one. So what's the idea of the Doppler
Wait,
effect?
what's the oh.
Like closer it gets, orange here.
All right, so that's true, but that's not because of the Doppler effect. That's just a question of intensity.
The frequency is higher when it's coming towards.
Yeah. So the thing with the Doppler effect is that the frequency of the observed wave depends on if something's coming towards us or away from us. So when the ambulance is coming towards us, it makes a high-pitched noise. When it's going away from us, it makes a low-pitched noise, or lower-pitched noise. So it's, you know, right? It comes in towards us. Excuse me. Yes. So physics.
wait, I don't under. Can you just repeat that?
All right.
The frequency one.
So when we have a sound wave, what do you notice about a sound wave besides its volume? It's pitch. Pitch, right? What is its pitch related to?
Frequency?
Well, yes, but it's related to its frequency in terms of kind of describing it as a wave. So when something has a high pitch, does that mean it's a high frequency or a low frequency?
Low. High. Wait, say
High
it again.
frequency.
High
It's a
pitch
high
equals
pitch, it's a
high.
high frequency. All right? Low pitch, low frequency.
And what long wavelength?
How frequently, so you can think of it as how frequently it oscillates or how frequently the wave hits you. So like in the case of, when we're talking about water waves, I say it's how frequently I hit in the face. Like I hit in the face 2 times per second, and there was a frequency of 2 per second, 2 hertz.
So how frequently it?
That hertz is the unit of
Oh,
frequency.
that's funny because I don't hurt you.
Yeah. Well, it's always the great thing. You want a hertz donut? So you think it's a baked good because it sounds like a hertz donut, but
Oh,
really
and
what you
then
do is then you punch someone.
Hurts, don't it?
Yeah.
My dad did that one.
Comic gold.
Yeah.
Fortunately, it's not really good to use in a school setting because I really shouldn't punch
So
students.
my dad did it. He said
It's not like.
What is, I don't get how the punching correlates with the frequency.
Wait, the joke part of it or the actual part of it?
The actual part of it.
So let's say if I get these water waves, right, and I get hit in the face twice per second with a water wave, it means the frequency of that wave you can think of as being 2 hertz, 2 per second. There are 2 waves.
2 hertz per second.
Not 2 hertz per second.